Comparison of C# and Java. Polymorphism. Java and C# are both fully object-oriented languages. Another primary concept of object-oriented programming is polymorphism. Poly means many and morph means form. Polymorphism means the ability to take more than one form. The behavior depends upon the types of data used in the operation. In real world, you are a person, which person is a base type, and you are a more specific representation of that type. There are many people that inherit that type, of which you are a concrete implementation of that type. You have your own attributes, qualities that go beyond just a general person. For instance, we all have a blood type, shoe size, arm length, and many other properties, but we each add our own implementation to the person interface. Polymorphism allows you to invoke methods of derived class through base class reference during runtime. It has the ability for classes to provide different implementation of methods that are called through the same name. Polymorphism provides at least two benefits. The first benefit is the old code can use new code. This is arguably the biggest benefit of object-oriented programming because it allows you to extend or enhance your system without modifying or breaking existing code. Secondly, it gives you the ability to group objects that have a common base class and treat them consistently. As an example, if we have three different object types like line, circle, square, I can treat them all as shape objects because they all derived from the shape base class. Polymorphism in Java and C# can be implemented in two ways. They are method overriding and method overloading. Method overriding is a class redefines a method of another class using the same signature. Runtime polymorphism is done using inheritance and virtual functions. Method overriding is called runtime polymorphism. It is also called late binding. When overriding a method, you change the behavior of the method for the derived class. When we think of polymorphism, we think of a method's implementation being determined by a variable's dynamic type. The static type of a reference type variable would be the type used in the variable's declaration. This type cannot change. For example, some fruit always has a static type of fruit. The dynamic type of reference type variable is a class of the object being referenced. The class must implement the static type of the variable, but inheritance and interfaces allow any number of classes to support this static type. Here, both the fruit and orange class implement the type fruit. We can assign objects of each to the variable some fruit. Java supports polymorphism by making all of its methods dynamically bound. The implementation of a method will always depend on the dynamic type of a variable. Here we see that calls to color and shape change depending on where the variable is referencing a fruit object or an orange object. By default, C# does not allow a method to be re-implemented. An example is the color method declared in class fruit. Although color method can be re-implemented by orange, it can be hidden so that the variables declared to be type orange access the one declared by the orange class and not the one inherited from the fruit class. Using new keyword allows a new version to be implemented which hides the inherited one. Strictly speaking, new is not required as its absence generates a warning rather than an error. In the bottom example, we see that the fruit version of color is executed regardless of the variable's dynamic type. Using virtual keyword, you allow a method's implementation to be revised. The virtual keyword states that the method will be dynamically bound. This is the case with the shape method in fruit class. Derived classes can use the word override to specify a new implementation that replaces the inherited one. This is the case with the shape method in the orange class. In the bottom example, we see that results of call to shape will vary depending on the variable's dynamic type. Compile time polymorphism is method and operator overloading. It is also called early binding. In method overloading, several methods with the same name can be defined but distinguished by their signature. They must have different types of parameters. Creating a new object instance triggers that class's constructor method. The following code utilizes a basic constructor that accepts no arguments. The basic constructor initializes the member variables with empty strings. Upon further investigation, it is discovered that often the objects are created with known names but sometimes only the last name. You can use method overloading to create multiple method versions, but each has its own method signature. The signature defines that parameters are accepted by the method. For example, here's the method signature for the previous constructor person. This method can be overloaded to accommodate first and last name or only the last name. And two methods with the same name in class must have different parameter types or a different parameter count. If not, the compiler will reject them. The class may now be declared as follows. In the code, if you observe display method is called 2 times, display method will work according to the number of parameters and the types of parameters.